What's going on, everyone? Welcome to LetThereBeMath again, and in today's video we're going to be talking about how to integrate a binomial function such as the one given here. Now in the previous video we were able to derive a general formula for any power n that would allow us to integrate this function, and we saw that this behaves in a very similar manner to just the function x to the power of n, in the sense that all we need to do to find the integral is to essentially add 1 to the power. We're going to place that at the bottom, n plus 1, and we're going to multiply that power by whatever was already in front of x. And we derive this by basically looking at the same function and finding its derivative. Now in this video we're going to go through a few examples just to illustrate how to use this method for a variety of different situations that you may encounter in textbooks or exams. So let's go through the first example. So we have 3x minus 1 to the power of 99. So we can apply the formula here. That's going to be 3x minus 1 to the power of 100. And now we're going to divide that by the new power, which is 100. And we're going to multiply this denominator by 3 because we have that constant 3 in front of x. And as usual, let's not forget the arbitrary constant of integration, c. Now we can simplify this further if we just write it as 3x minus 1 to the power of 100 divided by 300 plus c. And we can also check that this answer is correct simply by finding the derivative of our final answer. Now let's move on to the next example. We now have 1 minus x to the power of 2. So once again we're going to apply the binomial formula. So we have 1 minus x to the power of 3. And then we're going to divide that by the new power, which is 3. And now if you notice, there's a constant in front of x, which is 1, but it has a minus sign at the front, which means that we're going to have minus 1 times 3 in the denominator. And now we're going to add the constant c. So now to simplify things, we just write this as minus 1 minus x to the power of 3 divided by 3. Plus the constant c. Now what happens if you're given a function like this one? You have a rational function and now you have something that looks like a binomial expression in the denominator. Well, the first thing we know is that we can express this as a negative power. So let's write the integral as 4 plus x to the power of minus 5. And now this has the exact same form that we're expecting from our general formula. So now let's apply this to this expression. We're going to add 1 to the power, which means this is going to become minus 4. So that's going to be 4 plus x brackets minus 4 divided by minus 4. So I'm just going to put the minus sign at the front here. And then we're going to add the constant c. Okay, so that's going to be our final expression. And the reason I didn't have to multiply by anything here is because we have just a 1 in front of x, so we know that's going to stay the same in the denominator. The same applies if you have a function that is just to some rational power or some fractional power like this one. So we have the square of 1 plus x. How do we integrate that? We can first of all start off by writing it in the alternative form, 1 plus x to the power of half dx. And now we have a power of half, so all we need to do is add 1. So we're going to write 1 plus x to the power of 3 on 2 divided by 3 on 2. And now this is going to be multiplied by the constant in front of x, which is just 1 in this case. And then we add the constant c. Now of course if we want to make this a little bit more readable, we can just bring that 2 from the denominator all the way to the top. So that's going to become 2 times 1 plus x to the power of 3 on 2 divided by 3 plus the constant c. And that's going to make it more neat. Now the last one we're going to be looking at is we have a fractional power in the denominator, but we need to simplify that first. So we're going to start off by writing that as 10x minus 3, and now this is going to be the same as the power of 7 divided by 2 dx. And now we can express it as a negative power. So that's going to be 10x minus 3 to the power of minus 7 on 2. Okay, so I'm just going through each step here. And now we can continue that. So let's integrate that. We're going to add 1 to the power. That's going to become minus 5 on 2. So we have 10x minus 3 to the power of minus 5 on 2 divided by minus 5 on 2. Let me just move that up just slightly so you can see it better. So let's just get rid of this section here. And we're going to end up with 10x minus 3 to the power of minus 5 on 2. And now we're going to divide that by minus 5 on 2. And the next thing is we're going to multiply that denominator by the factor in front of x, which is 10. So that's going to be times 10. And then we have the constant c. And then for the last part of this question, we're just going to rearrange that slightly just to make it a little bit neater. So let's have 10 divided by 2 becomes 5. And then times 5 is 25 in the denominator. And the minus sign is going to come to the top. So that's going to be minus. And then we have 10x minus 3 to the power of minus 5 on 2 plus the constant c. And that's going to be our final answer. Now there's a very particular exception to this rule, and it not only applies to the binomial expression with the right here, but it also applies to x to the power of n. And it is what happens when you have something like this. You have 1 over x and you want to integrate that. Well, we know that if we were to express that as a negative power, x to the minus 1 dx, then by applying the formula we know of already, we're going to add 1 to the power. That's going to become x to the power 0. But then, since we need to divide by the old power, that's going to require us to divide by 0. And we know this is not a defined quantity. So in this case, we can't really apply the same formula for the particular case where the power is minus 1. And in the next video, we're going to explore why that is the case and how we can actually integrate this type of expression. As always, if you guys enjoyed this video, make sure you hit the subscribe button, and I will see you guys in the next video.